Hello all, welcome back Data Science Brain. In this video, I'll be showing you 5 Pandas tricks that will save your life as a data analyst. These are not your basic tutorial tricks, these are the ones I wish someone told me on day 1. And we'll be using the classic Titanic dataset that comes with Seaborn so you can code along. So let's dive right in. First of all, we will start by importing the Titanic dataset. So we have loaded the Titanic dataset and it has 891 passengers, multiple columns, and some messy data, which is perfect for learning. Alright, let's say you're analyzing the Titanic dataset and your boss asks, hey, can you give me all passengers above age 30 who survived the crash and were in first class? So you will naturally do something like this. You will do like filtered df is equal to df of df, where age is greater than 30 and what I need an extra bracket here, and you will do an ampersand and we will say like df of survived. So we want all the passengers who survived, right? So we'll say survived is equal to 1, and you will do another ampersand and you will say df, he should belong to class 1. That was our requirement, right? So class is equal to first. So this is what normally you would do, okay, when you want to get all the passengers above 30 who have survived and who are in first class. And yeah, you will get the result correctly, okay. It can be done and it is normal. But what if I tell you that, there is a much better way, that will look like plain English, like an SQL query. So, I mean, look at all those brackets and parentheses. If you forget one or, like even one ampersand or parenthesis, boom, there's an error, right? And good luck debugging that because, plus what if you need to add more conditions, like you will be putting more brackets and, ampersands and etc. So it becomes completely unreadable. Now watch this, okay? So I'm going to write here plain English, to get the same answer that we can see above. Okay. So filter df is equal to, I'll be using something known as a query. Okay. So this is a pandas querying function, and inside that I will write something like maybe age greater than 30 and survived equal to 1. And now this is where most people make a mistake. They will write like class equal to first, just like how Google Colab suggested me. So it's really not good that Google Colab suggested me this because it is wrong, okay, because we cannot use in query like reserved keywords like class directly like this. So we have to put it inside like this, okay. So now this will give me the same result as above. See, you can see the same result that we have done using all these parentheses and ampersand and everything. This messy code can be done very easily in plain English like this. So that's the power of the df.query, the query function in pandas. Now there's one more thing. You can even use Python variables inside your query with the @ symbol. Okay, so you don't have to even mention like minimum age is 30. Okay, you can just use a variable, and this will allow you to do this querying dynamically. So let us set the age as 30, and maybe let us also write like the class and survived as well. Okay, already Google Colab has given me the autocomplete as well. Okay, so we can set up variables like this, and you can maybe dynamically load values for this. Maybe you can change it to 30, 40, 50 or below 30, and you can use this @ symbol, @ symbol inside this querying to use this Python variables inside the query. Okay, so this will again give us the same result. So right now this time Google Colab was wise enough to put this inside this codes. Okay, so you can see it has given us the same result as above. Okay, so you can use Python variables as well inside this query like query function in pandas. Okay, now some of you might be thinking, why do we need to write something like this for something as simple as these 3 column querying. Okay, actually this is not the exact use case for this. Okay, I mean, for this you might be able to do this directly. It is not a big deal, you can count the number of brackets here and adjust it. But for something like this, okay, here you can see how many brackets are there, and if you miss some of this, I mean, this can get double as well, right? I mean, for some really big data sets, this can be many columns that you'll be using for querying. And this is where actually you see the power of querying. Okay, like you can turn something like this into a plain English sentence like this. Okay, and you will still get the again, as you can see, I have told you, don't use like reserved keywords directly like this. You have to like use this chords here, and you can see you have turned this ugly mess into plain English, and you got the same result. So that's the actual use case, where you can use something like a query for querying multiple columns from a dataset. Okay, so imagine you are cleaning the Titanic dataset for analysis. So you need to remove passengers with missing data, filter out any invalid ages like negative numbers or zero, or maybe create age groups like child, adult, and senior, and finally only keep the survivors. So most people, including the past me, would be writing something like this, like maybe df is equal to df. First thing is will be to remove passengers with missing data. So drop an a subset is equal to age, uh, and then what, the next thing is filter out invalid ages. So we will be doing something like df of age. Maybe we don't want any age below 0, and then the create age groups, right? So we will say something like age group is equal to pd dot cut df of age. Now we need to cut this into bins, like for different age groups, like let's say I start from 0, then till 18, then till 60, and till 100. Okay, and we will add labels like child, then adult, then maybe senior. Okay, and then what, finally we will be as we said, we will be only keeping the survivors. So df is equal to df of df survive equal to 1. So this is what normally we will be doing, right? I mean, and let us check the data. Okay, so this is what normally we would do. Every age greater than 0, we have binned it to like different classes as adult, child, etc. So this is what normally someone who is new to Pandas would do. But like look at all those df equals df statements. Like it's repetitive, right? I mean, it's too hard to read, and if you're like me, you will accidentally skip a line and wonder why your results are wrong for 30 minutes. Now here's where a pipe comes to your best friend. Like let us wrap each step in a function. So let us write, so that this is also helpful, because like we can reuse this thing. Okay, like let's say data frame, and so this thing will basically okay, yeah, remove the missing values in each column. Now I have ordered all the functions corresponding to all the data cleaning steps, which can also be reusable. Now watch the magic. So I'll just write df.clean is equal to, it is already giving me suggestions, like we will pass all these functions through pipes. Okay, and we will combine it, and and we will get back the results the same way as we have done above. Okay, so that's the magic of pipe. Okay, we can combine all these ugly code, write it in a better, more reusable functions way, and then we can use pipe to beautifully convert this into crystal clear format. Like it reads top to bottom like a recipe, right? I mean, And here's the best part. Now these functions are reusable. Okay. So like working on another data set, just pipe it through the same functions. You can get don't to change the logic, just modify one function instead of hunting through your code for every place you filtered edges. Okay, so I wish someone had shown me this on day one, okay, because it would have saved me so many headaches. So that's really helpful to have. Now again, another thing that commonly people do is feature engineering. Like let's say you are doing feature engineering on the Titanic dataset. So you want to create several new columns, like maybe calculate fare per age to see if older passengers paid more. Maybe flag whether someone is an adult. Calculate the total family size by adding siblings, spouse, parents, and children. And maybe to determine if the passenger was traveling alone. So the traditional way will be something like this, like df fare per age. You will manually do something like this, df for fare. I have personally done this. If you have watched my previous Titanic dataset machine learning project, you might be seeing the same thing. Okay, I'm pretty sure I have done this myself. So as you can see, it does the job, in a couple of steps. But as the number of features that we want to build increases, this is going to get real messy, and it's definitely not readable. And there is no way you can uh, you know scale something like this by doing this. Now there is a better way to do this. This works, but it's boring and repetitive, so you have to type like df like a million times, and if you're chaining operations, forget about it. So that's where df dot assign comes to help. Okay, so we can say something like df dot assign, and maybe open the brackets, and fare per age is equal to lambda. We write a lambda function x, and fare now x by age. Okay, so I have chained it like this, and it looks like clean, right? I mean, it looks clean and chainable. But you might be thinking like, I mean, what have you done here? I mean, it's almost the same effort and almost look as ugly as the above one, right? But here is where it gets really cool. Notice how I created family size here, and then immediately used it to create ease alone. Like, isn't it cool? Because you can reference columns as you create them. Okay, so that's something really powerful. And there is something even more powerful that we can do with this. Like, we can say, I'll just copy and paste this, and maybe after ease alone we can maybe say something like family category or something, like category. And we can do a little bit more uh, little longer operation. Like, we can use the family size here, and maybe we can do the bins thing that we have done above for 20. Okay, so this is basically going to divide the passengers into different family category. Like, is he living alone, is he having a small family, small family, or does he have a large family? Okay, I can create something like this. And there is many more things, many more really complex feature engineering that I can do by using df.assign. So that's the beauty of this thing. This is something that is going to take a lot of effort to do if you are going to do it in a normal way. Now if you think that's all it can do, you're wrong. Like, there is many more chaining that can be done on this. Okay, like we can maybe remove these things, and maybe do something like okay, I can put this in a group, and here we can even chain a query here, something that we have learned in the top sections. We can say is alone equal to false. Maybe we only need people who aren't alone. Okay, and then again we can change this. We can add another change to this. Maybe we can say assign like maybe age, family, what, survival maybe. And we can write a lambda function, x dot group by family size, you know, and what do we need? We need survive, right? Okay, so we can add more things like group by or transform to this. So the possibilities are endless. We can chain anything to these functions. So that's the power of chaining. This completely changed how I write data pipelines, like clean, readable, and you never have to worry about accidentally overwriting your original data frame. So that's really powerful. So picture this. Your manager walks over and says, I need a summary of passenger fares by class. Show me the average, median, minimum, maximum, and standard deviation. So your first instinct will be to do something like this. First class mean. Okay. So you will say df of maybe class equal to first, and you will do something like fare and mean. Okay. So similarly, you will do it for the rest, like mean, median, and standard deviation, right? Or maybe the minimum value, uh, median, and okay, and so on and so on, right? So this is what you will usually do. So like that's like 15 lines of repetitive code, right? I mean, if you need to add another class or metric, then good luck with that. But we can do so much more by using group by and aggregate. So we'll say fair summary is equal to df dot group by, and we will group by class, and we'll take fair, and we will find the aggregate for mean, median, min, then max maybe, and what else, maybe standard deviation. Okay, so we'll just print it. It has no attribute. Okay, of course. See, so all it takes is just one line of code, and you will be getting mean, median, min, max, standard deviation. The entire summary of the different classes of passengers in the dataset. So like one line gives you complete statistical summary. Like it's really much more better than writing 15, 16 lines of code, right? And actually it gets even better. Like if you want to if you want different aggregations for different columns, then like you can do something like this. I will copy here. And let us say by class, and then you need to aggregate by using different okay, maybe by fair, mean, median, max. It already given me suggestion, so I will just take it. So let us just do it till max here. Okay, mean, median, let's say median and min, max only. Okay, and I can copy paste this like this, and maybe I need to do it for the survived column as well. So I'll just paste it like this, and let us try and print this. See, it is so easy to get the mean, median, and median, min, max for the different like different columns, different aggregations as well. So that's the power of aggregate alongside group by as well. But there's one more thing that makes aggregate really powerful. Okay, like as you can see here, we have created some custom functions here. Okay, see, we have written some repetitive, I mean reusable custom functions here for finding age range, survival percentage, and fare category. And you can use this aggregate function to just pass in all these functions to this, like, and mixing these built-in functions, custom functions, and even inline lambda functions all in one clean readable statement. Okay, so this literally will save you 2 hours of work, like at least 2 hours, when creating an executive dashboard. So instead of writing separate calculations for every metric and every group, you just define the functions once, and let aggregate handle the combinations. So one pro tip, like you can even rename columns in the output by using tuples like new name function, etc., and your reports will look more professional right out of the gate. Okay, so this last one is a lifesaver when dealing with real world messy data. So let me paint you a picture. So you are given a data set where each passenger could have multiple ticket numbers. Maybe they bought ticket numbers for their family members. Your data looks something like this. Like tickets in the tickets column. You can see John has two tickets, Jane has one ticket, Bob has three tickets. Okay, so like this is a nightmare to analyze, right? I mean, you can group by ticket, like you can't count individual tickets, you can't do anything useful really. So how to fix this? So in the old way, how you would do it, like you will be writing a uh, maybe something like a for loop, right? So you'll declare this, and maybe let's say for idx row in this messy data. Yeah, I gotten luckily I have gotten the Google Colab suggestions. And now if we print the result, maybe let's say result is equal to pd dot data frame explore rows. And if you print this, maybe you will be able to get the results correctly, right? Yeah, but see, it looks like 8 lines of confusing code, right? I mean, you cannot I mean, for someone new, you can't understand this easily. And if you forget to include a column, you have to rewrite the whole thing. So like now watch the magic of explode. Okay, so you will say like clean data is equal to messy, oh sorry, caps lock was on, clean data is equal to messy data dot explode. Okay, tickets dot reset index drop equal to true. So now let us print this after exploding. See, you got the same result in just one line, replacing a whole for loop. Messy, like this is actually a nested for loop. Okay, so that's the beauty of this. That's one line. Each ticket gets its own row, and all the other columns are automatically duplicated. So it's like magic, but it's just smart pandas. So now let me show you the real power with a practical example. Say you want to count how many tickets each age group has. So we can do something like ticket analysis. We can take the clean data and dot. Let us use something that we have learned just before. So we'll say age group is equal to lambda xpd dot. So this is something that we have done above, okay, in just few examples before. And we will do some binning. We will bin it to different age groups. Let's say 50, 100, and let's put labels. What do we label them? Label them young, middle, and maybe say adult and senior. Okay, and now what we will do, we can maybe we can do group by, right? I mean, we can do so here we have assigned, so we can do something like, sorry, okay, we can do group by age group on tickets. And maybe we can now use this to count. Okay, so we can use count as well. So now let us print the ticket analysis. Okay, so as you can see, like without explode, this would have been nightmare, right? I mean, you have to do all this for loop, and after that you have to do, I mean, without explode as well as without using assign and all, doing this is going to be a like 20-30 line of code. Okay, it's like this would have been a nightmare to do that. So another a particular scenario, real life scenario is that you might be receiving data from a JSON API. Okay, so I'll show you an example. So imagine you got a data type like this. Okay, like you can see that this is going to be multiple for loops to extract data into a data frame format from this, right? I mean, name has multiple names as arrays, emails that are, again, nested arrays. So, like, to clean it up, by using what we have learned just now, it's just, few lines of code. Okay. Other than the lines and lines of for loops that you will write, you can just do like this. What did we learn? Like user data dot what we need to export. We need to export emails, right? So let us first do that, and we'll do something like rename columns is equal to emails, and we'll be extracting individual emails from that, right? And we will reset index and drop equal to true. Okay, so now let us print that and see. Okay, as you can see, you have successfully extracted all the individual emails from it and created a really beautiful looking data frame, okay, which we can directly work on right now. So that's again, a really powerful thing that this export can be used for. Like now we can maybe find the email domain distribution, maybe emails and domain. It becomes so much more easier to deal with data like this than in that JSON format, right? So maybe stick split, and so we need to find at to get the domains, right? So let us say plain emails domains. Okay, so as you can see, we have got all the extracted all the domains out of all the emails. Okay, so this one useful real life use case. Okay, so before someone who knew explode, they would spend around 2 hours or maybe more for writing nested loops to flatten this data. Okay, so with explode, we have did it in maybe 30 or 40 seconds, right? And I will also give you a bonus now. Okay, like you can explode multiple columns at once, if they have the same list. I will show you that. Like, so here you can see the list length is same, right? I mean, it's 2 here, and it's also again another 2 arrays here, and also here as well the list length is 2, isn't it? So it is consistent. So we can use x, maybe let's say expanded. Okay, whatever, I got a suggestion, I just took it. Expanded. So multi-list data dot explode, again it's same thing, but here comes the change. So in here we will give multiple columns. Okay, so that was the deal, right? We need to uh, explode multiple columns. So we will say reset index drop equal to true. Now we will print that, and you can see that we have extracted multiple nested columns at once. Okay, so this is perfect for time series data, in list, transaction histories, any nested JSON data. Basically anytime you have list lurking around in your data frame, explode is your friend. So now I will show you a quick bonus tip for which you will definitely thank me later. Like you have all used head to preview a data, right? Like you will write df.head, and this will give you like the first 5 rows of the dataset. But here's the problem. Like the first few rows of a dataset are not often representative. Maybe the data, I mean, they are test data, or maybe sorted in a weird way, or missing values that haven't appeared yet. Okay, so instead of using head, we can use sample. Okay, so we will say sample 5, and here we can see it has given us totally different random rows. Okay, so this will maybe we can put 10 here. So this will give us a better idea about how the dataset looks like. And you can see if I run it again, it will give me completely different number of different rows. Okay, so in this way we can quickly get, like every time you run it, you see different rows, right? So this can give you so much better feel for your data. You will catch the edge cases and weird values way faster. Like you can see there is a lot of NaN values. Maybe the NaN values were all in the middle of the dataset. Okay, so or maybe it is in random rows, you didn't see it in the first like the df.head, right? So like this will help you to get edge cases really faster. Okay, and there you have it. 5 Pandas tricks that will actually save your life, or at least save you from rage quitting data analysis. So which trick surprised you the most? Let me know in the comments. And if you want more Pandas content, drop a like and subscribe to our channel. You will be amazed to see that I have done only very few, but very useful machine learning projects. And in the coming days, I'll be putting more content into our channel. So this complete code is in the description below. I will be providing link to this Google Colab notebook with much more description. And trust me, these tricks become second nature once you use them few times. And this will definitely be in handy and will save your life many times in your data analysis career. So thanks for watching. I will see you in the next video, and happy analyzing.